Hi. One of the major problems that the students have trying to do the Simplex Tableau is whether they are doing it correctly or not. In this example that I have developed for you, I'm going to show you how you can generate a simple Excel worksheet and apply it to a Simplex Tableau. Well, let's go to my web page and go to the operations research bar and then go to the solve problems. Let's pick up a problem, and I have selected problem number 7 for you in this demonstration. Problem number 7 is a maximization problem, has 4 variables. All constraints are less than or equal to 0, and all variables are non-negative. So it's a basic, simple maximization problem that we want to solve it. In the same page, you will notice that there is a solution of the problem posted. First, we have converted the problem into standard form, and using the standard form, we have set up the first tableau, our basic feasible solution, and the basis of the first iteration. The first tableau will be S1, S2, and S3. The tableau has been filled. Selections have been made based on the simplex method rules, and X1 is the entering variable, and based on the minimum ratio, S2 will be the leaving variable. So from that point, you go ahead and iterate once, and in the next tableau, you will get a new set of variables in the basis. Of course, it's an adjacent extreme point, so there's only one of the variables changing. The solution is posted in that example, so you can have that and follow that. I'm going to just show how you can develop a Simplex Tableau in Excel using just the regular commands of Excel without any fancy work needed or any additional software. In this case, I've selected the Tableau iteration number 2, which has X4, X1, and S3 as its basic variables. When you go to Excel, I have done this to reduce the time of the video. I have already set up the entries that are needed for our work. You see the problem. I've placed an image of the problem there and an image of the standard form of the problem. The matrices, the different matrices which are given. First of all, the matrix A, the coefficient of the variables and the main constraints. The vector B, the column vector B, the right-hand side variables, values, and an identity matrix representing the coefficients of the basic variables S1, S2, and S3. So when you're looking at this basic information, the next thing that we need is what is our basic variable set, and in this case the basic variable set is X4, X1, and S3. Now we need to identify matrix B. Matrix B. Matrix B is the coefficients of the variables based on the order that I have for my XB. The first one, of course, being X4. Each one of the columns of A represent one of the variables, the coefficient of one of the variables. The coefficient of X4 are 1, -3, and 2. I will enter them there. The coefficient of x1 are 1, 2, and 0. I will enter those values in the matrix B as well. And the coefficient of S3. To find the coefficient of S3, I have to look at the identity matrix. S3 is the third column of the identity matrix, so I will put those values also in B, which is 0, 0, 1. The row vector CB is the coefficient of the variables in the objective function, same order. The coefficient of x4 is 3, the coefficient of x1 is 4, and the coefficient of s3, because it doesn't exist in the objective function, is 0. So now that I have set up my basic information regarding this tableau, I'm going to be using the information associated with this tableau. As you notice, the worked out tableau in that page, in the solve problem page, you can take a look at the values, and you notice that many of them are fractional. So one of the things that at the start I will do, I will make sure that these cells are represented in fractions. You can have them with one fraction or two fractions, two level of fractions, three level of fractions. In this case, the most that I had was one level of fractions, so I will keep that as one of them. So the first thing that I need to do is find B inverse. The B inverse location, as you see in the main structure of the tableau, is where it is at that corner. Now I have to find the B inverse in here. So I will use the B that I have developed, and I will find the B inverse. Don't forget how we are inverting the matrices. If you are not comfortable, just take a look at the previous videos. In this case, I have to multiply B inverse by A, and I can use the B inverse that I have already calculated, and the A matrix is also at the top of the page, and we use the mmult matrix multiplication function of Excel to find our value. Notice that if the cell is not wide enough, you will get those pound signs basically telling you that the cell is not wide enough. Just drag the cells a little bit and the numbers will show up. From here, basically after you have calculated the B inverse, you can do different things at different orders, but in this order probably the work is easier. The next one that I will be doing is B inverse B. I have the B inverse, I have the B, little b, and I will just do another matrix multiplication, and the result will be shown in B inverse B. Again, same command, mmult, and identifying the two matrices required, and the answer will be given. Don't forget to hold Control and Shift before pressing Enter. Again, we need to increase the width of the cell, and we will get the numbers 2 and 2/5, 12 and 3/5, 15 and 1/5 are the values that are given in here. The next one that we are going to calculate is the value of CBB inverse. The CBB inverse. If you do the calculation, you will see that CBB inverse is going to be a 1/3 row vector. We are performing the work exactly just we talked about it in for the other cells, another mult, and we will get the answer for CBB inverse. After we have calculated the CBB inverse values, then to calculate the other values, for example, let me show you this value at this corner. That's a Z value. It's CBB inverse B. I have two options. I can use the CBB inverse that I have already calculated and then multiply it by B, by little b, or I can use B inverse B that I have already calculated and multiply by CB. Each one of them will yield the same answer to you, and it would be a number that after the calculation you will get that number. If you perform the work either way, it would be the same answer. In here I use the CBB inverse and I'm multiplying it by little b. Now the last one consists of two operations. One is a matrix multiplication, which is CBB inverse A, and then the result needs to be subtracted by that by C, which is the coefficient of the variables in the objective function. Although we can write it in here, it's much easier to do the matrix multiplication outside the Tableau and just do the subtraction later inside the Tableau. So I'm going to just find a space in there and do that multiplication outside. So I'm going to find space in here, and I will do the multiplication. Again, I can either multiply CB by B inverse A that I have already calculated, or I can use CBB inverse and multiply it by A, and both will yield the same results. In this case, I will be using CBB inverse that I have already calculated, and I will multiply by matrix A. The result will be 4.4, 10.8, and 3, and these are the values of CBB inverse A. Now I'm going to do the subtraction operation here. I'm going to subtract the elements of C from these values that I have calculated, and I'll just do it one by one. So for the first one, I will do the subtraction, and then I just drag it, and it would repeat the same type of operation with the next numbers. So you can do it one by one if you wish. The values of the basic variables, I'm going to type them in there. X4, X1, and S3. And the values of Z are always 1, 0, 0, 0, depending on how big the base is. So this is the final work for this stage, and I have completed a Tableau. For that specific for that specific basis. Now that I have created one complete sheet, I can go back to the problem and create similar sheets by just copying this sheet and placing them in the other sheets of this worksheet, and I use them for different steps. So let's go back to the first step, the first tableau that I had, and use that tableau for this operation. You can compare of course you can compare the tableaus and see how they would present each other. So let's go to the first tableau, and as a comparison, you can always compare the numbers and see how accurate they are, or whether you made a mistake somewhere. So I'm going to copy this worksheet and place it in the other sheet. And of course I just want to have everything in just one screen, such that you can all see during the demonstration what is happening, and accordingly, if there is a cell which is not showing up, you can just drag it and increase the size of the cell a little bit so all the numbers are in there. So now, going back to our problem, the first tableau for us has S1, S2, and S3 as basic variables. So we are going to go back to the worksheet, and on this new sheet that we have created, we are going to write them as they are supposed to be, S1, S2, and S3. And we are going to change the values of B and CB accordingly. The upper values are always fixed, so we are not touching those values. The values that for each iteration needs to be changed are these three. What is the XB, what is the associated B, and what is the associated CB. So I'm changing those values now, and notice that the table entries change. Now compare these table entry values with what we have at our first step, our first tableau. If you compare them, they are exactly the same thing. So I'm going to copy this and put these values in a new sheet. Again, I will do the same type of steps that I went through. Make it a little bit smaller such that it would fit my demonstration. Again, if there is a value that needs to be changed, I will change it. And as you notice, X1 is an entering variable, so I'm going to change that entering variable to X1. Accordingly, I will change the B by entering the X1 coefficients from matrix A at its proper location. Exactly, I will change the same things. I will exactly do the same thing with the coefficient of CB. After I have updated, the table values entries change accordingly, new calculations are done, and I will have all the numbers properly displayed. My next iteration, of course, is the one that I have already developed as my template, at sheet 1, so I'm not going to do that again. It is the same thing that I have already done, as we can see from our sheet 1. But we are going to create the next step, which is the final step, the final tableau of the problem. I'm going to copy this and place it into a new tableau, into new sheet. I'm sorry, into the new, I'm placing it into a new sheet, and again the same type of work, and it is x4, x1, and x2. So it's going to be x4, and I will fix what I forgot to fix last time, and x2. I will change the values of change the values of b accordingly. And the coefficients of CB needs to be updated to reflect the new basis. And the changes will automatically take place. With the values, we can adjust the cell width to see our actual numbers, and this is the final tableau of the problem that we were working on, comparing the values of this tableau with the final values would reveal that all numbers are the same, and there is an optimal solution reached. There is no negative value in the zero, so our problem is optimal. The solution is x4 equal 5 and 7/9, x1 equal 9 and 2/9, and x2 equal 8 and 4/9, and everything else, x3, s1, s2, and s3, they are all non-basic and 0. We can do some cosmetic changes and fix few stuff here or there to make it look good, but the essential thing is that the values are there. One of the things that you might notice is that at points you would see numbers like -0. Those are very, very small numbers, and for all practical purposes they are 0 values. If you do them by hand, you would see that they would end up to be 0, because this is converting a lot of values and variables and so on. That is what we're doing. So I fixed that x1 that I missed in the previous step. Now I have the complete work, and I can use this work. Now you can go ahead and do some more work in here also. For example, now that you have the work, let's say that you are actually solving the problem as opposed to already having the solution. Well, in this case, you have to do the identify the entering variable and leaving variable. That you can do. And as an example, I'll take the same iteration 2 worksheet. I check the 0 and there are still negative entries in there, so the problem is not optimal. I'll select the most negative number. In this case it's just 1. I will identify x2 as my entering variable. I will highlight that that column, the x2 column. To identify what is the leaving variable, I have to calculate the mean ratio. To identify which constraint is the critical constraint, and identify the critical ratio, which is going to be my mean ratio. In this case, I have to do the calculation. Just remember, we do this calculation for all positive values of the entering variable column. So for example, the first one, which is minus 2/5 on x2 column, has no problem. There is no need for do that, and the simplex method just tells you do not take that ratio. So I'm going to write that as an if statement, and I will write that as an if statement, and only will calculate these values for the actual negative number, for actual positive numbers. Now, for those of you who are comfortable with Excel, it's just a very simple if statement, a conditional statement. For those of you who may have forgotten a little bit about that, here is what it looks. I'm saying that I'm just doing that for for positive values, and if there is a negative, I'll just disregard it. So I have identified what is the smallest value on the ratio column, and that's my mean ratio. So I'm identifying my leaving variables. So the next iteration, in the next iteration, I would have x4, x1, and x2 as my basis, and that's what I will have in here, and those are the calculations that I have done. It's a very simple process. It requires you to work with it. There is always a important point to make about this, and you can save the work. Please just remember that this Excel worksheet is for verification of your work. You still have to know how to do the work yourself and have practiced and gained the skills to do the work accurately in a reasonable amount of time.